From concept to completion. 6 high-tech tools used to build the Burj Khalifa. Did you know that the Burj Khalifa broke new ground in terms of the machinery that was used on the project? It is common knowledge that the largest and most expensive versions of just about everything that was used on the project were utilized. We take a look at some of the PMV landmarks located in the tower. The following is a list of the top 10 tools that were utilized in the building of Burj Khalifa. Number 6. Piling. More than 600 deep piles are utilized during the construction of the Burj Khalifa. However, the vast majority are utilized to support the podium complex, with only 194 being utilized for the tower itself. The majority of the piling work was completed by Bauer Specialtiefbau in conjunction with Middle East Foundations. This required bores to be excavated for cast-in situ piles to a depth of 43 meters. The Bauer BG40 is capable of delivering, as its name suggests, 40 Newton meters of torque. Some people refer to it as the Rolls-Royce of the world of drill rigs. It seems to reason that there is no circumstance that we can conceive of in which you would require such a substantial amount of electricity for drilling pile holes. In the vast majority of building scenarios, 1/2 of this amount would be sufficient. The 194 deep piles each had their bore, which was dug in 2004. Each one of them was intended to be cast in place, and as a result, they needed to have a significant depth. In the location of the Burj, the ground conditions were good. The earth was soft but not unstable, which made it simple to dig into. Number 5. Pumping. In the process of pumping concrete to a new height, a machinery record was set. However, the measurement did not exactly match the one that is frequently cited. In the latter half of 2007, a series of concrete pumps capable of producing high pressure was required to propel the mixture to a height of 601 meters. The manufacturer of the pumps organized a photo call and utilized a large poster to announce that the figure had set a new world record. But, not long after that, it was determined that the concrete needed to go a little further. So, an extension was made so that the concrete could be moved to a distance of 606 meters. Bypassing the mixture via high-pressure trailer-mounted pump operating at a pressure of 200 bar, a Putzmeister 14,000 shpd, the mix was able to achieve such astonishing heights. To account for the height difference of 606 meters, it took the concrete roughly 40 minutes to get from the hopper being filled to being discharged from the delivery line. With this installation height, the concrete volume in the line amounted to around 11 cubic meters, which indicates that there were nearly 26 tons on the pump after every piston stroke, which is equivalent to the weight of 5 large elephants. Number 4. Lifts. Even if the external lifts that were employed during construction were not particularly sluggish, it would still take around half an hour to reach the top of the building due to the size of the structure. In addition to this, the construction site required the daily presence of thousands of people. Hence, once workers reached the upper levels, they rarely descended. The occupants of the building and the people who come to visit no longer have to wait around thanks to some rapid new machinery that has been placed in the building. One record that was previously held by Taipei 101, which is currently the world's second tallest structure, was surpassed by the Otis lift installations in terms of the speed at which many of the elevators travel, which is claimed to be more than 10 meters per second. Number 3. Cranes. They are elegant and intriguing, and for a while, it seemed like everybody's favorite topic was about them. The high-level cranes at the Burj have always been mysterious, which has kept the identity of the person who operates the very highest unit a secret. Rumors were floating about the Indian on top of the world, in which it was speculated that he was given honorary citizenship in the United Arab Emirates and that he was paid a king's ransom. All of this was nothing more than idle gossip. The figure had become more of a mystery man due to Amar's refusal to let the media have any access to him, and this was most likely due to the developer keeping the exact height of the structure a closely guarded secret, a figure which the high-level operators undoubtedly knew. Amar had refused to let the media have any access to him. According to the numbers, the cranes moved more than 63,000 tons of material over 45,000 hours. In most cases, the load consisted of steel reinforcing beams. Nevertheless, welders' equipment, scaffolding, generator sets, and fuel tanks for diesel-powered. Cranes were also among the items that required to be moved to the appropriate floor. Number 2. Dismantling. Because the tower was designed such that pieces of the cranes could be lifted as new levels were constructed, setting up the 3 high-level cranes was a very uncomplicated process. Yet, to bring the towers down, some more creative problem-solving was required. In November 2007, the first high-level crane was brought down to level 99 to be prepared for use as a recovery crane in the future. The subsequent high-level crane to be taken down in October 2008 left one notable machine seemingly stalled at the top. To get it to floor 159 in a second, the smaller crane was required to be hoisted up there. The process of deconstructing the building could now get underway, thanks to the presence of a crane on this floor as well as the one on level 99. The procedure began with the crane lowering itself from its working height of more than 700 meters to the ground below. The crane was able to dismantle its portions of the mast and lower them to the ground until the boom and power pack were in the same position as the level 159 recovery crane. Number 1. A stone machine representation of the Burj Khalifa. In many architectural blogs, there was widespread suspicion that the temperature of the Burj Dubai can vary by as much as 8 degrees from the top to the bottom. This gave rise to some very outlandish hypotheses regarding the physical properties of the extremely tall skyscraper. One of the most egregious examples can be found in a piece that was published in the German newspaper Das Spiegel. The piece, which read as follows, is one of the best examples available, and makes the following outlandish claim. The tower is so enormous that the air temperature at the top is up to 8 degrees Celsius lower than at the base. If someone ever had the bright idea of opening a door at the top and a door at the bottom, in addition to the airlocks in between, a storm would rush through the air-conditioned building that would destroy most everything in its wake, with the possible exception of the heavy marble tiles in the luxury apartments. There is no denying the fact that there would be something of a chimney effect, and for this reason, skyscrapers and other tall structures with lofty atriums contain revolving doors that are never totally open to the air outside. But the most significant obstacle would be an open shaft that descended 850 meters straight into the basement. The facility management has likely worked out a solution to this problem so that it will never be permitted to take place. The fact that this is true has not stopped others from speculating on the internet that this downdraft would be so powerful that it might influence or even trigger extreme weather across continents. The possibility that a janitor could bring on the next Cyclone Ganu is a peculiar one to consider. How was the video? Did you enjoy it? Post your feedback in our comment section below, and subscribe to our YouTube channel for more updates.